When a user initiates a transaction, it is sent to the lead validator along with the other transactions from other users. The lead validator compiles them into a block and starts executing them. The block is then sent to the rest of the network for other validators to execute and confirm that everything is valid and consistent. Once verified, validators vote to confirm the block, adding it to the ledger and moving the network forward. Now this happens in 6 stages. Let's look at the first one, users. Usually, users start by creating and funding a wallet application. A wallet cryptographically generates a user key pair consisting of the public and private key. The public key acts as the unique identifier for the user's account and is known by everyone on the network. This account can be referred to as a data structure that stores all the information of the user's interaction with the Solana blockchain. Public keys on Solana are represented as 32-byte base 58 encoding strings. Here's an example. On the other hand, a private key is like a password or access key that gives permission to access and modify the user's account. Now, signing a transaction with your private key is how blockchains handle authorization, and Solana private keys are also 32 bytes in length. Here's an example. Private keys can also be derived from mnemonic seed phrases, which is a human-readable way to back up your private key. They're usually 12 or 24 word long. These key pairs are the 64-byte combinations of the public key and the private key. Solana uses the ED25519 elliptic curve to generate key pairs and for transaction signing. An elliptic curve is just a type of mathematical equation used in cryptography to create key pairs. Each Solana wallet address represents a point on the elliptic curve. The user uses their private key to sign the transaction, proving it's really from them. This signature is added to the transaction and can be checked by others using the user's public key to make sure it hasn't been changed and is approved by the real owner. This signature also helps uniquely identify the transaction. Now let's talk about transactions. A transaction is the only way to update the blockchain. They carry instructions such as transfer tokens from one account to another, or swapping one token for another. Each transaction is atomic, meaning either everything the transaction attempts to do happens or the transaction fails. Transactions contain 4 parts. The header points to the list of account addresses and tells the network which of those accounts need to sign to approve the transaction. It basically marks who must give permission for the transaction to happen. Next in a transaction is the account addresses, which are a list of all accounts that the transaction will read from or writes to. Example like the sender account, the receiver account, the token account, etc. etc. Solana requires you to include this list upfront, which helps the network process transactions more efficiently. It can be tricky for developers, but it allows Solana to run transactions faster than many other blockchains. Recent block hash. Each time a block is produced by validators on the blockchain, it is given a block hash, which is a unique code that identifies each block. A transaction contains the block hash of a recent block. Instruction. This is a command inside the transaction that tells a specific program what actions to perform, which accounts to use, and what data to include. The number of instructions in a transaction is limited by 1. The size, and the max is 1232 bytes. Secondly, the number of accounts it can reference. Third, the computational resources it can use, which is measured in CU. When you send a transaction on Solana, the cost is split into 2 parts, a base fee and a prioritization fee. The base fee is always the same, 5,000 lampots for each signature. The prioritization fee is optional, but during busy times it helps get your transactions processed faster. This fee is very small and based on how much computer work your transaction needs. This gives validators a reason to pick your transaction over others. So the total fee equals the base fee plus the prioritization fee. This fee goes to the block producer, that is the validators. Now let's look at how users interact with the blockchain. When the user wants to do something, let's say swap tokens, the user connects their wallet to a DeFi application, allowing it to view the user's public key. The application builds the transaction with the details the user has specified. Example, the token, the amount, and the token that's being swapped. After building the transaction, the application then sends it to the user for them to sign with the private key. Once the transaction is signed, the application then sends it to an RPC provider. RPC simply means remote procedural call. They act like a bridge between applications and validators. They allow applications to submit transactions and also get data from the blockchain. Now in the next episode, we'll see what happens after the transaction is signed and submitted to the RPC.